Speaking of reliability, a podcast with good friends talking with you about reliability engineering topics. Welcome to Speaking of Reliability. This is Fred Schenkelberg.
And this is Enrico Belmonte.
Hey, Enrico. Thanks for, holding on and getting back in touch. I was out recording for the whole summer, but missed talking to you. So I'm glad we got connected again, and we'll catch up a little bit offline. But you had an interesting topic just as we're starting up here is on using data or data. I'm not sure which is which, or I always wonder what plural is. I think it's datum. Is that it? I don't know.
I don't know. You are a native speaker. I'm not.
I'm not. I grew up here. I can't speak English. Yet the idea is that you mentioned it just briefly, and I thought, there's a lot to that. We might have to do more than one session on this. But what did you have in mind when we suggested that?
First of all, Fred, it's my pleasure to get in touch with you to record this session. No, I was thinking about the role of data. I think that the engineers, the modern engineers, they should have good basics about reliability, so the classical one, but they should also be equipped with some knowledge about data analysis. Especially in terms of mission profile, I think, which is, to my opinion, quite a hot topic in the modern industry.
Right. Well, you're talking about different than being a statistician. The data analysis is kind of taken on a variant of being a statistician that deals with numbers and data. But when you say using data and mission provision, I'm thinking, temperature profiles, thermal cycling, how often is an item used or not used? How often is it idle? How often is it maintained? Transportation, vibration, all of those things we have ways to measure and collect data. And it's not necessarily time to failure data that us reliability engineers / statisticians tend to focus on.
Yeah. So if you recall the picture where you have the stress strength interference method, where you have the stress distribution and strength distribution, I would say that for the strength distribution there are a lot of well-established approach, whereas for stress distribution it's a little bit I wouldn't say more complicated, but generally like 10 years ago there were no chances, no opportunities to investigate it properly, so therefore people relied basically on assumption. Instead, right now there are a lot of data all around, and in order to analyze them, you should have some competencies in statistics, in terms of analysis of univariate distribution, multivariate distribution, clustering, machine learning, all a bunch of new competencies that they are more than, let's say, welcomed in the modern industry. So reliability engineer is also request to learn a lot about data analysis in order to be efficient and to leverage on the data that are available right now. What do you think about that?
No, I totally agree. And it's a big part of stress strength is a classic example of where in order to design something that has the robustness for the expected stresses it's going to see, you need to know what those stresses are. And not just, it's going to see 40C as a maximum temperature. Well, geez, I think in your neighborhood last year you got above 40C. I think it was the summer you talked about it. So hopefully your phone worked just fine. But the idea is that the standards and the tables, the old style of here's the min max of this, that, and the other thing just doesn't cut it anymore. It's not reflecting reality. And I think coupled with that over the last 20, 30 years is our ability to measure stuff, and sensor technology has gotten much easier to use, much less expensive to use, less intrusive, all that kind of stuff. Now, one other thing is if you don't have good mission profile type data or the types of stresses you're going at, you have to be pretty creative sometimes. I worked with a game controller uh, team, and they were designing something. And one of the questions we asked was they wanted to or test the buttons. They were dome switches essentially, and so you deform this dome of metal, and it would make contact, and then it would spring back. And they said, well, how do you do this in the past? This is the first project you did with had buttons on it. And they said, oh, we put them on a pneumatic plunger and we push it a million times. I'm like, why a million? That sounds odd. He says, well, that's what the data sheet says it can do.
Yeah.
And I'm like,
Yeah.
well, wait a second. How often do people actually push the buttons on these things? And they had no idea.
Yeah, this is a new question, because in the past, as you said, people try to or confuse data sheet with requirements, which is a
Hmm.
typical mistakes engineers are doing. But generally, engineers are conservative guys.
Yeah,
They are trying to collect worst case assumptions.
right.
And that's probably was possible some years ago, but due to the cost pressure that we experience in the modern company, that's not is not feasible anymore. And but think about temperature and humidity. No,
Yeah,
temperature and humidity. Temperature is a well, let's say, measured quantity, but
yeah.
humidity, no, nobody knows about it. Yeah. So therefore,
Not
what
yeah, not really. And just to explain that a little bit is humidity is it's called relative humidity because you have to know what the temperature is.
yeah.
And 85 relative humidity is pretty meaningless of moisture content uh, as opposed to what the temperature is. So if it's 45 C, then it's really hot and muggy. It makes it feel very, very hot. Yet if it's minus 10 C, 85 RH means it might be snowing, and that's about it. It doesn't feel humid. So
Yeah, I
I
think
think
there are
a lot
two
of people
aspects.
misunderstand that it's not an absolute in and of itself.
I think there are two aspects here. So I definitely agree with you that in when considering, let's say, aging mechanism, it should always combine temperature and humidity.
Hmm.
For
Hmm.
example, electronics is much more sensitive to the combination of temperature and humidity than just to temperature.
Yep.
And in that case, as I said, engineers take a conservative assumption, so they consider pretty good all the temperature distribution, and then say, okay, let's take the highest relative
Yeah.
humidity the product can encounter. So
Was
it
well, I've seen it as a shortcut before we had reasonable ways to measure all this stuff. And temperature, we've
yeah.
had weather stations for centuries that if we chose to, we could go get that information and get a distribution out of it. Yet even then, we didn't do it. Nowadays, with our tools and equipment we have available, there's no reason not to. Yet I still see a lot of reluctance and just, for example, that button pushing thing is the problem was that a million was not enough for some of the buttons, and it was orders of magnitude too much for others, and it took time to push every one of them for a million times. So just by and I ran into somebody that had a device that could intercept the Bluetooth signal. It would just
Mhm.
they called it a sniffer. It would gather the data that was being sent from the controller to the computer to those games console. And I just stuck it in a big spreadsheet and I looked for the signal that said push button A and then tallied it up. And so I wrote some scripts that just pulled out the information I needed from all this coding that went back and forth. And it was and then we found it we did it about 30 times with different people that were in for gameplay trials on new systems and new software and stuff like that, and it just happened to piggyback on that study to gather the data I was looking for. And it took a couple of days. That was it. And a couple hours with the spreadsheet, and I had all kinds of not the best of distributions. I only had 30
Mhm.
samples, but I knew pretty much what the mean and standard deviation was.
Yeah,
Distributions were for how often these particular buttons were, and then we had data about what kind of style of game player they were, whether they were,
yeah,
and it made a difference. But it was when I went to the engineering team with this data, they said, "Well, we never knew it was done like that, and it was all anecdotal prior to it." And I said, "Yeah, you just have to be a little creative to gather this data, and then you can make way better decisions." And the second point is that for some things, they just did what you were describing. They go to the max, or they go to a high margin, or the high
yeah,
end of what they think the stress would be applied. Oh, it'll get above 10 foot-pounds, right? Okay.
yeah,
Let's open this book about how hard somebody can pinch something, grab something in their fists. And there's tables, all this human factor stuff. And they had the average value, and it had distribution type data in some of them. And it went up to 25 foot-pounds, or what, I don't remember the actual numbers, but people could grab something incredibly higher pressure than what the engineers even thought was possible.
yeah,
So it surprised them. But then it's like, do we want to design something that can withstand this one person in the world that can do this? Or are
yeah.
we going to go like the 90th percentile, or who actually uses our products, and let's measure their capability. And for me, it's always fascinating. Let's see what people really do and measure it and use that information to design to.
Yeah, I think you touch a good point. So I would add some reflections. The first one is that, as you said, we need to investigate how the product are used. So the use case analysis is one crucial
Mhm.
aspect of design for reliability, and I think people should always do that carefully, separating between the intended use, the extreme use, and the misuse. Of course, as you
Yeah.
said, we cannot design just as people apply extreme uses every time. This not cannot be the target of the design. However, extreme uses can happen, and they should be covered separately, I think.
And if it does fail, then fail safe. That was a big
Yeah,
push for us with this
yeah,
gripping thing we were doing, is if somebody crushes this polymer, does it break sharp? Will
yeah.
it cut them if it breaks? And so we did go to the extremes and find out where it broke and how it broke for the extreme cases, yet we didn't design it to withstand that much pressure.
Yeah, but you have investigated how it behaves when in case of extreme uses.
Hmm.
Definitely, they should be taken into account. Yeah, it
Yep.
cannot be neglected.
Yep.
Second point that you mentioned is about the normal use, and I think is we started talking about data.
Hmm.
And there are a lot of new approaches. Let's say they are not pretty new, but they are new in the terms of application to reliability. For example, clustering or multivariate data analysis. They
Hmm.
can help us identify what is the median usage. Yeah, and median usage is not cannot just be described in terms of number of cycles, but could also be related to temperature, could be related to the duration. So there are multiple parameters that should be included in order to describe the median usage.
Hmm.
And
Hmm.
therefore, what I'm saying, hey, let's analyze the data and let's have the competencies um, to analyze them properly. So we can start with univariate analysis, looking at number of cycles, for example. But even in that case, even if you have the number of cycles per month, for example, you have a distribution, how do you scale it up to 10 years, 15 years, 20 years usage? This is
Right.
also a question uh, that is important to address, and statistician can do that definitely, but reliability engineers say in their toolbox like 5, 10 years ago, there were not these questions. Now these are new question to be addressed. Yeah,
Hmm.
and that's is I think a new frontier for reliability engineers. Get good data in terms of acquisition, but in terms of usage also. And I think there are a lot of things to do in this field.
Well, yeah, well, there is, and I have no doubt about it. Talking to the choir here, is because I thoroughly enjoy, and that's why I've gone out of my way in so many different programs to go find the data, go create it if we don't have it, or go measure it. Yet I kind of grew up in industry in a world that's just what we did. If we don't have, like, I had a a general manager that if we were making a proposal or talking about what we're working on, he goes, "Show me the data." He was always interested in, where did you get this data? How did it accumulate? What kind of measurement error did it have? He was a stickler for, you talk with data. It was,
Yeah,
and so it was early in my career, and it's always been very useful for me in my overall career. But you're
yeah,
right. There's so many other tools out there, and ways to look at stuff. And it's amazing what you see is when you put four or five, it's hard to see it in one plot or one screen, but three variables, and you put them in a cube, essentially, and you can rotate it on your screen. You can see patterns and associations and stuff that no single variate type data will ever give you. You may think these are related, but how are they related? And what kind of patterns do they create, and so on? It is super informative. And I know using our software, I've done it with higher dimensions where you get a three-dimensional slice of, say, 5 variables or 10 variables, and you can switch in one variable after another. And then you're stepping through, looking at these things in different combinations, and all of a sudden it becomes a crystal. It, instead of a cloud of points, it becomes super
yeah,
styrated and stacked and orderly, and like, well, what's causing that? So, and in that particular case, that surprised me was the measurement of one of the variables reacted, was interfering or something with a couple of other measurements, uh, but it wasn't a fine enough measurement scale, so it got binned into like five readings. It was 2, 2.2, 2.4, and so on. And it needed a much finer resolution in order to see what was really going on. So we're back to the lab on that one. But
yeah.
yeah, there's so many different ways to do this stuff, and just a little curiosity and a handful of tools, you can be pretty dangerous if you really understand the analysis techniques that are out there. You can be really effective.
Yeah, and I want also to mention the tools that are available. You just mentioned that. So there are tools like Databricks, Snowflakes, all the Python, let's say
Hmm.
add-ons, all this kind of tools that like 5 years ago were just emerging. Now they are, let's say, they are tools that are commonly used by the engineers. So they are needed to analyze data,
Hmm.
also
Hmm.
artificial intelligence, algorithms, and so on. They should be part of the toolbox of reliability engineers. Therefore, I started this discussion with you saying that data should be, let's say, considered, even if the fundamental, let's say, theory of design for reliability should be there, should not be replaced by data. One
Hmm.
of the
Hmm.
point, one of the point that we always talk about is understand damage mechanism, understand what are the leverages for doing good design, and these are, let's say, the key skills for reliability engineers. But if the reliability engineers get supported by data, they are much more effective than in the
Yeah.
past.
Well, I'm thinking of tools like derating and stress strength calculations are just so much improved when we have good data behind them,
Yeah,
and good understanding of the distributions and the details of it. Yet also material selection. If we're looking at, different polymer systems, and we need to know what temperature environment it's going to see, when does it soften? What's the softening point for this particular polymer? and what are our options, and what's the kind of distribution of stresses that that polymer is going to see, instead of just, oh, it's we're going to put it in a home, it'll never see anything above 40C or whatever, and we pick it off a data sheet. I think by asking the next set of questions and saying, well, here's the range of temperatures we're going to see, and here's how frequently they're going to occur, we can pick, we can optimize the choice of materials
Yeah.
much. And it's a, to me, that's a design for a reliability thing, yet procurement and material scientists and engineers are the ones that should be doing that and enabling them with much richer information, much richer data. It just enables them to make better decisions. I think
Yeah.
the data sets just have to be trusted and useful.
And that is one of the challenges, to have good data and then to process them.
Yeah.
Okay,
Yeah.
but I would say there are a lot of reliability approaches that can be just applied, but they can deliver really bad results if the data are not good enough. So,
That's right.
yeah, so the source of information should be trusted, and data is, to analyze them, to check their plausibility. That's really a key challenge for modern reliability engineers.
One question, and might be hopefully one of our listeners knows the answer to this one, is that when cell phones first became these smartphones type stuff with like screen and touch screen and all that good stuff on it, you only had to drop it once or twice before it shattered all kinds of places. Now they got all kinds of cool new technology that it survives that. Yet, can you imagine being the person on that team saying, "Well, how many times would somebody drop this?" And it's
Mm.
equivalent of today being $1,000 investment, and they were very rare, and it was the new hot thing or whatever. And I remember people treated him like with just so carefully because it was so expensive and such a neat new thing, and they didn't want to scratch it. It's like getting a brand new car. You don't want to take it on the road, any gravel roads, because it'll get
Yeah,
all dinged
yeah,
up,
yeah, yeah.
kind of thing. Yeah, after the car gets a couple hundred miles on it, or the phone has been in your hand for 2, 3 years, the it falls off the table and it's fine. And then, you accidentally drop it or this or it's the usage pattern. What I'm getting at is the usage pattern is not fixed.
It's
It's
not
not,
fixed. Yeah,
yeah, it's not open and close this cabinet door 10 times a day, every day, all the time. No, it will change with time and with the behaviors of your people that are using your products. I'm thinking wash machines. All of a sudden the house gets bought and sold, and it used to be a single person. Now it's a family of six. That machine's going to get used a whole lot more.
yeah, and that creates a lot of challenges when it comes to forecast distribution.
Yeah,
You have, for example, couple of years of data, but you need to forecast 20 years distribution. How can you do that
yeah. There's
without
a
knowing what is, let's say, the life of the people and how the pattern can change? You
yeah,
need to
yeah.
take some confidence, yeah, but it's quite challenging and also really fascinating, I think.
Yeah. So I'm going to leave it open to our listeners is, how do you, one, I'm just curious about any interesting or creative things that you've had to go measure and learn from. I think success stories of, just get the data and see what you got kind of thing. And then how do you in your organization use data to improve the reliability designs of your products and so on? And kind of we often ask for questions, and there's plenty of questions you may have if you're listening to this, and we'd be more than happy to entertain those and get you answers if we can, or talk about it here on the show. But if you got success stories, that might be pretty cool. We'd like to hear some of those. You can do that. You can even leave us a voice message that we could play as part of a show over at accendoreliability.com/go/SOR. And there's a button there for SpeakPipe that lets you record a message to us, or you could leave a written message. And Enrico and I and the other hosts of the show are available through LinkedIn and our About pages. So you don't have to show us your data, and I know a lot of us have proprietary stuff, but if you know of a great resource or a good story, we'd love to hear it. Oh, good topic, Enrico. I'm glad you brought it up. So Do you spend the day with your spreadsheet today? Is that why this was top of mind?
Yeah, we had a workshop on data, so therefore I thought it
Oh,
was a
okay,
good,
there you go.
yeah, well,
It
was
was
a good
top of
topic for
mind.
today. Yeah.
Yeah.
Thank you very much, Fred.
Thank you. Talk to you later.
Bye.
Bye. Thanks for listening to Speaking of Reliability. We invite you to join the conversation. If you have a question or a topic that you think we should discuss in a future show, please let us know. You can find a comment box below the episode show notes, or just leave a note as part of a review on iTunes.